Hello everybody, welcome back to the shop. Finally getting around to this project. This gear has been sitting broken on my bench for about 3 years, and finally decided to put this thing back together. So this gear is off of the Ruston Hornsby 7HR, and it's a governor gear. Broke it trying to get it off the shaft because in Ruston's infinite ingeniousness and wisdom, this gear is a heat shrunk fit, and it has a key, and it has a set screw to hold it on the shaft, and it doesn't really need anything but a set screw because it's just a governor gear and it's not really taking a whole lot of load. Anyway, it broke, I broke it, taking it off, so I've got to stick it back together. Luckily, what I got going for me is that it is low load, and that'll make my confidence a little higher that it's not going to break while operating. So what I'm going to do, I already did a little bit of preparation before I started this video. I did some beveling. Because of the teeth and the shape and reasons, I beveled some on one side and some beveling on the other side. And there is also one tooth missing, so I'm just going to build that up and then grind it to form. Oh, and the other thing that's working in my favor is that this is cast iron. So what's nice about cast iron when it breaks is that it just breaks. It doesn't bend and yield first. So this rough surface here is basically it's an alignment tool. It keys everything together, so this just clicks into place really nice. So this plate is going to be my fixture. I cut myself a little hole and I made a mark where to align the gear. Because I'm going to be welding on both sides, and I want to weld on both sides anyway to prevent it warping one way or the other. Once I clamp this down onto my fixture plate, I'll do some tack welds here, but I'm also going to need to tack weld the other side, so I'll just stick my welding rod through that little access hole. So that's the setup. It's fairly basic, and again the broken edge of the cast iron, that is why I did not V this all the way out. I did leave a little bit. I might, looking at it now, I might V it a little bit more, but I think it will be plenty strong as it is. And I can also leave the weld beaded up. I don't have to grind it flush for any reason, so that'll add a little bit extra too. So this gear has already been heated a lot while I was trying to take it off, so I've already driven out any oil that's in it. It may have gotten some oil on it just sitting on my bench, so I'm going to give it another heat with the torch just to drive out any oil. And we'll clamp it down, heat it again to give it a preheat. And again, of course, you want to put a decent amount of heat into the joint, but you also want heat in everything, because you want everything to expand and then everything to contract as one. So then once it's heated up, I'll do some tacks here, some tacks there, and then finish weld it. And then once it's welded, the best thing to do would be to put it in like a bucket of ash or wrap it up in a welding blanket or something to insulate it. Some people use a gas grill and put it in the gas grill and slowly turn the heat down to slowly cool the part down. I don't have any of those things. I suppose I could fire up the charcoal grill, but I don't feel like doing that. So I've had good enough luck just after welding it, hitting it with the torch, waiting, going back, hitting it with the torch again, and then each time I hit it with the torch, I just slowly pull the torch away a little bit more, so that does give you a little bit of fluctuation in the temperature, which isn't great. But in general, you're going from a high temperature to a low temperature, and it's worked well enough for me. So that's the overview of what I'm going to be doing. That's all the talking. Now the rest of the video we'll be doing. Alright, so the next thing I do in preparation for a job like this, since I'm not super familiar with nickel rod, is I find a piece of cast iron in my junk pile and I run a couple practice beads. And that one there, as you see, it's cold. It's kind of beaded up, doesn't look very good. Same with that next one there. So right there, that's the temperature that works great for regular 6011, 95 amps I think it is, but I had to bump it up to 124 and it made a fairly nice bead. So now I got the temperature set on the welder. I don't have to mess around with that. So let's bring the gear over here and we'll get the torch on it and we'll have at it. So here we go. Direct heat to everything. Get it all nice and warmed up. Okay, we're ready to go. Got some noise going on because of my ventilation fan. That stuff welds nice. This is the welding rod that you definitely smoke down to the filter due to the cost. I'm also finding that with 6011 I do a whip and pause welding technique, but with this, just a nice slow drag. Okay, I'm officially done. It's still really hot, so now I'm just going to sit back, relax, and just hit it with a torch gently every so often, increasing the time in between when I do that, just to cool this as slowly as I can within my means. Well, here we are. It's the next day, everything's cooled down. And it's not the prettiest weld. There are some kind of divots, and like right here it still looks cold. Actually, now that I'm talking, this weld here I put on afterwards. I had turned the heat down because I was building up this tooth and I saw it was a little bit low here. So this weld is cold, and I'm not surprised because the welder was set colder. But I got lots of weld in there regardless. That weld underneath it looked pretty nice until I welded over it. Here's the other side. I welded my, well, you can kind of see where I cut it off. I welded my C-clamp on there accidentally. I couldn't get the cutting disc in there, so I just had to cut the foot off and sacrifice that clamp. But it turned out pretty well. So really the only thing left to do is clean off little things like this little divot sticking out there, and I'm going to reform this tooth. I made sure to put on lots of extra material. You see it's way built up extra, because just easier to do extra and grind it off rather than the other way around. And all I'm going to do is just use the angle grinder and a cutting disc and just carefully whittle away at it. And I've done this in the past, I don't know if I'll do it here, but in the past I've made a pattern out of sheet metal. Basically it looks like a thread, a tooth gauge, I guess you'd call it, or a thread gauge. Just a little sawtooth thing that sits in there. And I might do that, I don't think I will, but you could, if you're doing something similar, make yourself a pattern with a good set of teeth. And as you grind away, you put that pattern over it to check your progress. This might be a little more challenging to do it that way because the tooth, it's a little hard to see but with the shadow, but the tooth does widen as it gets to the outside diameter there. Just a hair, but it does. So anyway, let's get grinding on that tooth. So I started by roughing out the outside shape of the tooth. I got this curve, the inside and outside curve set. I got the top ground down so it's, just about flush. Then you see what I did on the top. I scribbled some Sharpie on it, and then using just a pair of these calipers, I measured the pitch from the center of one tooth to the center of the next, and found the center of where the new tooth is going to be, which is where that strong line is. And then I measured the width of the inside edge of the tooth, marked it, the width of the outside edge of the tooth, marked it, and then I scribed some lines there. So now I have something to follow while I hog off the rest of the material. Now that it's pretty close, best I can tell by eye more or less, I'm just taking out the caliper, measuring the width of the top of the tooth up here, the width of the tooth there, the width of the base of the tooth, just any sort of dimension that I can get the calipers on. But you can see it's pretty good. Off by a couple thousandths on the bottom, still a little bit fat, so I'm just going to keep whittling away. I got the profile all set. I did go undersize, I don't know, 10 thousandths or something like that on the measurements that I made, just because it might be, I might have made the tooth a little bit too far this way or too far that way or something. So I figure a tooth that's a little loose is better than a tooth that's too big and going to cause interference. And the last thing I did, I actually overdid it, but I adjusted the height of the tooth because it was still a little bit high. So I gauged it just by putting a straight edge on one tooth and rocking it back and forth and just getting a feel for how much that straight edge rocks back and forth. Then I went to the tooth I'm fixing, and it rocks back and forth just about the same. I did too much on the bottom because it doesn't rock at all, but that's okay because the tip of the tooth doesn't do a whole lot. It's the center of the face that really takes the load. Of course the tip is important to feed itself in, but it's only down by, maybe 20 thousandths or 10 or something like that. So that's really it. I'm going to just kind of look it over once again and verify that it is the way I want it to be. So anyway, man, I am happy with that. I was dreading this job so much, and that's why it sat on my bench for 3 years. But it's finally done. It's as good as it's ever going to get. And actually one thing I never checked, I'll check it later, but I want to see how flat this ended up. Hopefully this piece didn't warp one way or the other. But at this point, it is what it is, I don't think it's super far out. That looks pretty good, just doing a quick glance at it. But anyway, everybody, that's that. Thank you for watching. Hope you enjoyed this. I actually enjoyed this more than I thought I would. And thank you to my friend for this welding rod. It welded beautifully. I'll be in touch with him to see what brand this is, because I really like it much better than the Hobart. I've never been happy with Hobart. Regular stuff like 6011 doesn't run well, and the nickel rod doesn't run great either. So anyway, thanks for watching. Leave a thumbs up if you enjoyed this, which I'm sure you did. Hit the subscribe button and like button. Keep up to date with all the projects we got going on here. That's it, everybody. Thanks for watching, and come on back for more. And hey, one day maybe you'll see this engine running.